Good afternoon, beautiful humans. So let's add to our notebook yet again. Let's open up our table of contents, and we're going to add today and talk about rates, ratios, and proportions. So diving a little bit into some baby equations today and looking at kind of how we solve some things and kind of how we change some things, and it'll be good fun. So we're going to call this rates, ratios, and proportions. I feel like if I'm remembering correctly, you guys may have done some of this stuff last year, maybe even in 7th grade. So hopefully, again, it feels a little bit reviewy still. I think most of first semester Algebra 1 truly is. So 10 and 11. And then if we go to page 10 and 11, we're going to leave 10 blank for now. And then on page 11, now this should be the next one in your notes packet. I know the last one we had to search for it. You're looking for the one that along the side says ratios and proportions. It should be the next one that you have, okay? And again, this one is gonna fold backwards, like a backwards book. And then if we want to do a cute little cut, we could do a cute little cut to get 2 doors. One where we're going to talk about ratios, and then the other about proportions. Okay, so that can go on page 11. Okay, so let's actually talk about ratios first. And what a ratio is really just a shortened version of saying the word rational. And what a rational number is a fractional number. So ratio is just a fraction. It can be written 3 ways. We can do it with the little dotties like this. And so you could have the ratio 3.4, but you say it 3 to 4, the way that we say it. You can write it as a fraction, which is my favorite way to write a ratio. So, a number example would be like boop, boop, boop. And we would say that one like 3/4. Or we can just, write it with English 3 to 4. Or, another way you could say it is 3 divided by 4, I suppose. So 3 divided by 4. And then when we are looking at ratios on their own, there are 4 different ways that we can determine whether 2 ratios form a proportion or not. And so what it means to be proportional is to be the same ratio. So I have one ratio on one side, one ratio on the other. Maybe they don't look the same, but I can figure out if they're the same one of 4 different ways. Okay, and if they are, then they are proportional. Okay, so we take a look at here, some examples of ratios. Do the ratios 3/5 and 21/35 form a proportion? So really this is just asking the question, are these ratios the same? So maybe we'll write that over here. This is a low-key question. Are the ratios the same? Proportion is just a fancy way to say that. It's like it sums up that sentence in one word. Okay? So one strategy that you could use is you could identify if they have a common multiplier. So what I mean by that is if I go from 3 to 21 and multiply something, is it the same as when I go from 5 to 35 and multiply something? And the answer is yes, because 3 times 7 is 21. And 5 times 7 is 35. So since we times the same thing both times, yes, they are a proportion. They are the same, they're equal. So again, it's kind of like when we were talking about intro to equations, we're trying to see, is this a true statement or not? Is 3/5 the same as 21 over 35. And I can tell because they both are multiplied by 7 over here, and I get the same thing. Okay. Another way to determine if something is a proportion or not, or is 3 over 5 the same as 21 over 35, is we can use cross products. So if I multiply diagonally, so if I do 3 times 35, is that the same as when I multiply diagonally the other way, 21 times 5? So 3 times 35 is 105. And 21 times 5 is 105. So yes, because 105 is the same as 105. So again, I have proved that they are proportional. They are the same ratio. Okay, another way to do this is we can simplify the ratios. So on this side, 3 over 5 is already simplified. I cannot simplify anymore. But on the other side, I can simplify because 21 and 35 have a common factor of 7. So I can divide 7 out of each, which gives me 3 over 5. And so now I can see that once I've simplified, these two sides are the same. So yes, we are a proportion. The ratios are the same. Or our last way of doing it, which I'm just no. I mean, it requires a calculator. We want to do math here. It makes our brain stronger. But I mean, if you really, really did, 3/5, if I type it into my calculator, if I do long division, is 0.6. If I type into my calculator 21 over 35, or if I do long division, it's 0.6. So, I mean, the answer is not no. That's confusing. Yes, they are proportional, but no, don't convert it to fractions. I hate, or convert it to decimals. I hate it. Okay, I actually don't want to talk about proportions just yet. I want to take a little detour over here and talk about rates. Because rates are just another type of ratio. So a rate is a ratio that compares amounts with different units, which is super powerful. Like, I don't have to compare apples to apples. I could compare apples to alligators. I don't know why you would want to do that, but you could. And that's a really interesting thing and can be very useful, like when you're shopping or when you're driving or whatever. So a really good example of a rate would be 20 miles per 2 hours. And then you can reduce that, which is super cute. You could talk about 100 apples per 1 alligator. Again, they don't eat those, but I don't know, maybe. So another type of rate that we want to talk about really quickly is a unit rate. And a unit rate is a little bit better than just a rate because it simplifies down to 1. And that can be really good to make comparisons. So if I want to compare, like a really good example of this is unit price. Like when you're grocery shopping, you can look at the little tags at how much things cost per unit. And that's really powerful because then you can compare which one is a better buy. Like if I'm getting toilet paper, right? If I want to see how much it costs for one roll of toilet paper in like the 36 pack compared to the 18 pack to figure out which one is a better buy, it'll tell you the unit price. So that's why it's really good to understand. So using this example over here, a unit rate is just when my denominator is 1. So when I reduce to a denominator of 1, or your bottom number. So using that same example, like I said, that would be super simple to reduce. And we'd have 10 miles per 1 hour. Or I could just write that as 10 miles per hour. Cute. So again, we want to use that unit rate to do something like comparing. So when I compare rates or comparing rates, we want to do an example of that really quickly. So which is better? We could use that toilet paper example, but I have another example for you too. So which is better? 6 bagels for $3.29 or 8 bagels. I should have done donuts. What was I thinking? For $4.15. So which one of those is better? So to do that, we want to first set up our ratio. So our ratio here for these two different things is going to be 6 bagels to $3.29 and $8 or 8 bagels rather to $4.15. Now the really weird thing here is if I want to compare, I need to use a unit rate. So when I reduce used for comparing. That little note, I want a different color. Okay, so to make my denominator 1, like I can't just divide here like super simply like I did before, because I don't know, 3.29, I don't know that it goes evenly into 6. I just need to divide the denominator. So on each one of these, let me get a different color going on here. So on this one, I'm going to divide the bottom by 329 to make it 1. But since I did it on the bottom, I have to do it on the top as well. And that'll get me my unit rate for the 6 bagel thing. Then over here, I need to also make my denominator 1. So I need to divide by exactly that number, 415, so that I'm comparing the same denominator so that we can see which one is the better buy. So when I divide this 6 by $3.29, oh my gosh, I need my calculator. Haven't done it yet. Boop, boop, boop. 6 divided by 3.29 is $1.82 per 1 bagel. And then when I do the other one, we got 8 divided by 415, and we get $1.92 per 1. So that tells me which one is the better buy, because this one is cheaper. The 6 bagels for $3.29 is our better buy. So that would be our answer. Okay. Another really useful thing that includes rates or ratios is converting. So if I'm, talking about miles per hour, I could convert that to like feet per second. Or if we're talking about apples per alligators, I could convert that to, I don't know, feet per otter. I don't know. It doesn't make sense. It only makes sense with the units of measure that we actually have. So like feet, centimeters, ounces, liters, things like that. So if a car, we're going to do the most basic example here because that's really what we use it for. So a car is traveling at 55 miles per hour. What is the car's speed in feet per second? So I always love doing this, and I know you guys will do this sometimes in science a lot too, like converting. But for me, I always felt like it was really fun. So you start with your 55 miles per 1 hour, because that's what we are given. And we need to change that all the way down to feet per second. And so really it's just about cross canceling, and it's a fraction, which is why I loved it so much. So if I start with my miles, first let's start with hours. That's easier. So I'm going to times this, always times by fractions to get to what I want. So I'm at an hour, and in 1 hour, I have 60 minutes. I can't jump to seconds right away. And so the thing that you need to make sure is that your units are always opposite each other so that they cancel out. And when I have 1 hour, it takes 60 minutes. And then I'm not quite to seconds yet, so I need to multiply by another fraction where for 1 minute, I have 60 seconds. And then I have per second, because second is going to be at the bottom here because all of our units cancel each other out like this. And so we're left with seconds in the denominator like I wanted. And these things are equivalent here, like 1 minute and 60 seconds is equivalent. So my fractions, I'm really just multiplying by 1. But then I also have to convert the miles to feet. And that is actually something I had to look up. Like, I don't know by heart how many feet there are in a mile. Like, I had to look it up, and it's 5,280. Okay, so I need to times by 5,280 feet, and I want that on top because that's the units I'm trying to get to. And when I travel that many feet, I've gone 1 mile. And that's really good because your miles will cancel each other out. Now, the ones don't really matter, and we're really just multiplying a bunch of numbers in a numerator and a bunch of numbers in the denominator. So I'm going to do like 55 times 1 times 1 times 5,280. Then I'm going to divide by 60 times 60, which is 3,600, and I also didn't do that yet. So I have to use a calculator on this. I'm just not that good. So 5280. My numerator was 290,400. Holy moly. Divided by 60 times 60, which is 3,600. That's going to be 80.6 repeating feet per second. Feels like you're going fast when you say it that way. Okay, last but not least, let's jump over to proportions again. So again, we were talking about ratios. When two ratios are the same, so set equal to each other, then you have a proportion. But if I don't know what one of the numbers are, I can use that fact to solve, okay? So if I want to solve for something in a proportion that I don't know, I would always use cross products. So I multiply diagonally. So 6 times x is 6x. And I multiply across diagonally, and 5 times 9.6 is a number. And then I bring my equals down. Okay, so the equal sign stays. So over here, 6 times x is just 6x. 5 times 9.6 is a number that my calculator is going to tell me because I hate decimals. 9.6. 48. Oh, how nice. That's so cute. Then to solve for x, and we haven't really talked about this yet, but I think maybe you remember, I can think 6 times what is 48? And I think that's 8. Just use a little mental math there. Okay, so we're going to just try maybe 2 in here. So I'm going to try this one right here. I would multiply it diagonally. So we're going to have 49 times 4 is the same as 28 times W. 49 times 4, that's a really big number. We get 196 equals 28 times W. I would have to think 28 times what is 196? And that's pretty big. That's 7. Now getting a little bit trickier over here. I'm going to skip this one because it's similar. But when I have 2 numbers, I need to be careful because I'm doing 12 times that whole thing. So parentheses are really important because we're going to have to distribute. And then 5 times 4. So we're going to have 20 on this side. On the other side, I need to distribute. So we'll have 12x plus 12. And then I have to think 12 times what plus 12 is 20. And I think that's like not a whole number. And guys, if you're getting stuck at this point, that's really okay. As long as we can sort of set up the proportion for now, I think I'm fine, because we do have to talk more about solving, but maybe you kind of remember how to solve this. And I'm going to do it right now. And if you're like totally like, what? It's okay. We're going to talk about it more later. I would subtract the 12. So 12x equals 8. And then I would divide by 12. And that's how I get that fractional number smaller than 1. We can reduce, 4 goes into both, so 2/3. Alrighty, hopefully that kind of goes okay. Let me know if you have questions.